And we're back. I took the moment while the other video was uploading to sketch out somewhat melodramatically the path to victory or defeat. All right, given the situation. So just as a recap, what we have to do here is we were supposed to perform 3 tasks one at a time. Okay? And if at any way along the road we get a victory, right, we get a success, we stop the game, we've won. So the question was, what is the probability of winning? Okay, so now again, you don't have to do this with these types of problems. You can just quickly multiply and get your answer, but it's helpful just to start off and see what I'm doing here. Okay, so this is your starting point for task 1. What's going to happen is we have to flip a coin, right? And there's 2 things that could happen. Either we get a heads or we get a tails. And I wrote the odds of either that event happening as 1/2, right? Okay. Now, but what the rule says is that if we get heads, we win. The game stops. So I circled the win in the blue, right? I can get here, and then if I do that, I win and I'm done. Okay. But supposing I don't, well, then that means I'm now here. I flipped a tails. Now I have to roll my die. And it said for that one, if we get a 6, we win. Well, that's this path right here. The odds of that happening is 1 out of 6. But if we get there, then blue, we're done, we won. But there's a 5/6 probability that we would not get a 6, right? That's what that little squiggle is supposed to mean, not 6, okay? So supposing we don't get a 6, well, now we're here. Now the last thing that we have to do is, the third task is that we have to pick a card. If we pick spades, we win. If not, we lose. Okay, so again, we're at a crossroads. 1/4 of the time, we would end up getting a spade. We'd win, because that's the odds of that happening. 3/4 of the time, we would not get a spade. Okay? So the question is asking, what's the probability of winning? Well, there are 3 different ways that we could win, highlighted in the blue. Either I just flat out get a heads, or I get tails and then a 6, or the third possibility, think about following the path to get to these different circles. Either I get a tails, don't get a 6, and then get a spade. So what I could do, if I wanted to calculate the probability of winning, we've got kind of an or, right? Either this happens, or that happens, or that happens, and if I add them all up, all those probabilities, I would end up getting the probability of winning, right? Okay, so then now that's kind of the long way to do it. There's a shortcut, but let me just set that up. So the 3 different scenarios are, either I flat out get a heads, and the odds of that happening is just 1/2, or I have to get tails then 6, and the odds of that would just be, remember, and we'd be multiplying these probabilities. The odds of getting tails would be 1/2 times 1/6. So I'm going to put that down, 1/2 times 1/6. Okay, the third route to victory would be going tails, not 6, and spade. And the odds of that would be 1/2, 5/6, 1/4. So I could write that out. 1/2 times 5/6 times 1/4. Okay? And then all I'd have to do is just add those things up, right? These are 3 alternatives that we could have for victory. So we know that with probabilities, we just add them. So that would get us to, well, that's just 1/2. We're done with that one. This would simplify to being 1/12, the odds of that happening. And the odds of this one happening would be 5/48. Okay? And if we add all these things up, we'd probably have to make the denominators the same. You can check my math here, but I ended up getting 33 after doing conversions, 33/48, which is equivalent to 11/16. Okay, that would be the odds of winning this game. Okay, the 3 different paths to victory. We just calculate the probabilities for each one and then add them up. Okay, that's perfectly acceptable, logically and mathematically sound, but there is a slight shorter way. Okay, instead of figuring out all of those different paths right there, sort of a shortcut would be to recognize, well, hold on a second. How many ways could we not win? So think about it. We're asking to figure out how many ways could we win. What's the probability of not winning? What path, oops, what am I doing here? I'm looking for, there it is. What path could we take so that we would not end up with a victory? Well, it looks like there's only one way that could happen, right? We'd have to end up here. We'd have to go this chain like so. We'd have to go start from our starting point, avoiding all the blues, right? We want to see what would make us lose. We'd have to get to here, and then to here, and then finally to here. So we could just calculate the only way that we could lose this game would be if we multiplied these probabilities together. 1/2, 5/6, and 3/4. And if we do that, let's hear what we get. 1/2 times 5/6 times 3/4 would get us to, what is this going to be? 15. Oh, we can simplify a little bit. It's 1/2 That's all much we can do. 5/16 are the odds of losing, right? Be very careful. That's what we calculated here in the purple. That's the odds of losing the game. Well, but if we were interested in figuring out what are the odds of winning the game, it would just have to be 100% or 1 minus this. So that would again get us to 11/16 would be the odds of winning. Okay, either way is fine. You can think to yourself, I could calculate individually all the different ways in which I could win, find the probabilities for each different scenario, and then add them all up. Or I could just figure out what's the probability of losing and just figure out what that is, and then we know that 1 minus whatever that probability is has to be the probability of winning. Okay, hopefully that made sense. I hope. Okay. Now, if you were not going to draw a diagram out, you could just think to yourself, we know it's 3 things, and I think in this case, I would calculate the easiest way to do it would just be thinking about how could we lose? How could we not win? So, the first task, we would move on if we got a tails, so that would be 1/2 odds of that happening. We'd move on to the third task if the second one we didn't get a 6, so that would be 5/6. And then we'd finally lose if we did not get a spades, and the odds of that happening are 3/4. So again, you kind of set that up, solve that. That gets us our odds of losing. And then we could just figure out winning from there. Okay? I have a feeling that I didn't make much sense there, but I'm just going to press on and hopefully that works. Okay, last one. Look at this one. Same scenario here, but this one it says if exactly one of these 3 tasks is successful, then we win the game. What's the probability of winning? Okay, this is, again, we've got different scenarios. We only want one. If exactly one of these is successful, then we win. So can't win 2 of them, can't win all 3, we can only win 1. Well, there's 3 ways that could happen. Either we win the coin game and lose the other ones, plus lose the other two, or we win the die game, plus lose the other 2, or last possibility is that we win the card game, but we have to lose the other 2. So I think you can kind of see where I'm going with this, right? All we'd have to do is just calculate, since the odds of either of these events happening, and remember, it's just exactly 1 is needed in order to win. So we could either win this way or that way. So we would end up adding all these probabilities. So let's just quickly do this. What are the odds of winning the coin and losing the other 2? Well, to win the coin, we'd have to flip heads, and there's a 50% odds of that happening. We'd also have to lose the card, or lose the die, and odds of losing, not rolling a 6, would be 5/6. And then also not getting a spade would be odds of 3/4. Okay? So that's the way that we would lose that game. And let me see, if we simplify that, hold on, I'm going to pause this because I want to work these out real quickly so we don't waste time on the exposition here. 1 second. All right, sorry about that. I'm old and it takes me a while to calculate stuff. Okay, I'm not going to simplify this, but I will just write down, if we multiplied that out, the probability of the winning via the coin would be 15/48. Okay, those are our odds. Now, winning with the die would mean we'd have to lose the coin game. Odds of that happening is 1/2. We'd have to win the die game. Odds of that happening is 1/6. And we'd have to lose the card game. So that'd be 3/4. And that all works out to be 3/48, are the odds of that happening. The odds of this happening would be to win the card game, we'd have to lose the die and lose the card. Whoops, the odds of losing the die are 5/6. Sorry. We'd have to lose the coin toss and lose the card, the die roll, and finally win the card game, and that would end up getting to 5/48. Okay, so these are the paths to victory. Since it's an or, any of these things could happen. We would just add those all up, and that would get us to 15 plus 3 plus 5 is 23, right? If I did my math right, 23/48. That would be the probability of winning in this scenario.